Hello statistics student, this video is for chapter 2.2. We continue on summarizing quantitative data using graph. And the third types of graph that we will use is histogram. So in chapter 2.1, we say if we want to summarize quantitative data, the four things that we want to concern about is center, variation, distribution, and outliers. So if someone gives you a list of data, like commute time or grades, right? A lot of time we'll say, oh, it's calculate the average. Yeah, that is a numerical summary. But if I want to be more complete, so like these numbers, right? 63, blah, blah, blah. If you are to tell people about this, you have to look at these four things. Now, in a small data set like grades, less than 20 data in a small range, you can use stem plot and dot plot. But in a large data set, just imagine if this is not from a class, but from 200 students in the whole school, and you want to summarize them, you would not use a stem plot or a dot plot. Instead, you'll use a histogram because it is used to summarize distribution of medium to large quantitative data. So data are first summarized into frequency classes, just like when we do the group the frequency table, and then graph it as bars. Now these bars would be contiguous bar, unlike the normal bar graph that can be used to summarize categorical data. So you will see histogram bar like this. Okay, so the horizontal axis is not the category anymore, but ranges, class range from 0 to 5, 5 to 10, 10 to 15, or whatever data value that you're about. If it's grade, then it's from 60 to 65, whatever range that you have. And the vertical axis is frequency. So the height of the bar represents how likely or how many data is within that range. So you can see it is a graphical representation of frequency distribution. And notice, the important thing is to distinguish it from a bar graph is there's no spaces between graph because data values are continuously, they are contiguous. And in a typical histogram, you should not have too little, you should not have too many bars. So usually it's from 5 to 15 bars. When you are sketching a histogram, we call it a histogram, you should label the axis and also the title. One thing the histogram is very good at, it shows the shape of the distribution. It shows center. Center is where most data cluster around. How they distribute, meaning where is most data distributed? Is it on the low side, the right side, or on the middle? And also it can show outliers. So outliers would be something like if I have a histogram like this where the bars are all contiguous, they tell you this is the highest part, and then all of a sudden, very far away from the rest, there is one bar that has a frequency of 1 or 2. That means there's 1 or 2 data that is far away from the rest, either the high end or the low end. We call these outliers. So visually, it's very easy to see compared to looking at a table. So let's do an example where there is looking at understanding how to use a histogram. So this is an example of a histogram. It summarizes a whole bunch of data. So summarize weights of players in a football team. So look at the horizontal axis are the weights. So the first bar is 180 to 200. And then we have a frequency. In this bar, the frequency is 2. That means there's 2 data value from 180 to 200. We do not know the actual data value. We only know that it is from 180 to 200. Likewise, the highest bar has a frequency 10. That means there's 10 players or 10 weights in this range, but we lost track as to what is the actual value. So let's look at what can be found by looking at a histogram. First, how many players are on the team? That means how many weights did I collect? So I can look at each frequency. So this class has 2. This has 10 by looking at the vertical axis. 9, 7, 4, look at the x-axis, the vertical axis 2, and then I add them together. Use a scientific calculator. 2 plus 10 plus 9 plus 7 plus 4 plus 2. That's 34. So I have 34 weights. That is 34 players. 300 is not the players. 300 is weights. Okay. How many players weighs 240 pounds or more? 240 is here. So how many players does it represent? This has 7 players, right? These bars represent the count. So that's 7 plus 4 plus 2, 13. What is this percentage out of the 34? We can also, I think, if we do not just want the count, we can actually also calculate the percentage. 13 out of 34, that is 38.2%. You use the calculator to do it. Can we tell the actual weight of the player from the histogram? No. We only know that there's 10 weights from 200 to 220. Are they all different? Are they all the same? Are they 201 and then are they all 220? We don't know. So no actual weight. So this is the difference between stamp plot and dot plot. In stamp plot and dot plot, you can actually recover the actual data, but not in a histogram. Are there any outliers? Do I see any bars that are far away, non-contiguous with the rest? No, there's no outliers. So histogram can tell a lot about a data after you summarize it. Now, the second things we want to do is to learn how to graph a histogram. Okay. Of course, you can graph it manually by doing a frequency table and then use manual graphing. But we have a lot of online tools that can help us to graph histogram. And in this course, it is important that we know how to do histogram so that we know how data are distributed. Is most of the data distributed in the middle, or are they on the low end or on the high end? And also, are there any outliers? Okay, so I'm going to do an example. So these are the steps. So what happened is we basically use StatDis. I'm going to show you how to do StatDis. So you go on to statdis.com and then you log on with whatever email that you have signed up with StatDis. So I have some old data. I'm going to clear them. Okay. So this is a blank sample editor. We call it sample editor because most of the data that we find, we assume that they are sample. I have the data already inputted here in an Excel spreadsheet, so I'm going to highlight it and copy it over instead of, enter them one by one. I copy. You do Control C, and then I do Control V to copy into StatDis. Okay, so this is the first step, and then I want to do a histogram, right? So let's look at the requirement in the paper. First, we say, okay, so these are all the data I have. I manually put in the Excel and I copy it over, but I want to use a class width of 10. That means each range has 10 number. The lowest value start from 20. So I start from 20 to 30, 30 to 40, meaning, right? So I'm going to do data histogram. Click. And then the histogram menu will show up. It's blank because we haven't, and our data is in column 1. So select the column. And then you have to tell, do I do the auto feed? That means just let the online calculator determine what we want to graph, or we want to do a class width of 10, but start from 20. Is it? Do I start from 20? Lowest value of 20 because our lowest value is 22. Yeah, 20. You don't actually use the lowest value. You use a nice number so the class looks nice. And then the last thing you do is plot. You can do relative frequency if you want to, but usually we just do frequency plot. So this is what we have. If you hover over it, you'll see that it tells you that this bar represents 20 to 29. This is 30 to 39. When we graph it on the paper, normally we just do 20, 30 like that, because presumably there should be no space in between. When they do this, they stop at 29, so there's a little space in between, but technically a histogram should not have these kinds of space. So you can see, if I am to graph it by hand, I would write it this way. I would write it as like this: 20, 30, 40. Just all the lowest class limit is good enough. And then when I hover over it, I see that, oh, this is 4 and this is 7. So I'll graph a 4. Now you do, for the horizontal axis, you don't have to start from 0 because this is just classes. 4, and then this is 7. You have to scale them properly. And you see how I do not leave any space. So you could do that, just 20, 30 like that. And then you can continue, copy all of them. Remember to label them. This is the commute time, right? So that's how you graph it and then copy it out. And this is frequency. You always have to write frequency. And then you can, to a title, this is a histogram. Histogram is summarizing quantitative data. Another method is still use this, but do it this way. Okay, so you would go to data. Instead of go to histogram to adjust the class width and the class start, you can do explore data and select the data value, which is column 1. You would have a histogram here. So it looks a little different. Because, well, actually, I think it's the same, because they are using you never need to enter any lowest value or class width. They would just do a default for you. They would do a default one. They would show you N, they would tell X, but they don't have like nice labels. They just say X values, Y value. You have to provide yours. So this is a good way to just do a one-off kind of exploring the data. We call it explore data. So let's do this. The second example: sketch a histogram of number of customers in a sample of store. So this is a number of customers. I use the default class of status. Okay, so 1234. Did I enter it? Let me see my Excel file, the video data. Yeah, I have entered it. 1234. All these I have entered it in the Excel file. I copy it. And then I go back to status. I say show editor, and I am going to download it into Control V, into column 2. So I have to remember that first one is commute time. This one is the store thing. And because I'm going to just use default classes, so I would just use explore data from column. Explore data from column. It would just do a histogram for you. So hide the sample editor. So this is, they will give us 5 classes. The first is 0 to 20. Okay, from 0, 20, 40, 60, 80. And it is 1, 2, 8, 3, 1. So that's what you do. So you go back and say, oh, I would use the default class. Is it 0? 0, 20, 40, 60, 80. What? I forgot what it is. 1, 2, 8, 3, 1. 1, 2, 8. 8 would be very tall. 8, oh, I think they're good. 3 is taller. And 80. Oh yeah, that's at 89. So 100, right? So this is the shape of the distribution. What's the shape? It's symmetrical, right? Symmetrical has another name. Later on, we'll talk about it. Okay, just symmetrical. Do I have any outliers? There's no outliers.